The diagram shows a metal plate consisting of a rectangle with sides x centimeter and y centimeter and a quarter circle of radius x centimeter. So this is a metal plate, this part over here is a rectangle, and this is a quarter circle. This quarter circle has the radius of x centimeter and the sides of this rectangle are x and y. The perimeter of this plate is given to be 60 centimeter, and in the first part of the question I need to express y in terms of x. So to do the first part, first I'll use the fact that the perimeter is 60 centimeter. These three sides are known, but this side and this curved side are not known. If this is y, then this would also be y. And for this side, we know that the circumference of a circle is 2 pi r. So for this side, the circumference would be 2 pi r divided by 4. The radius is given to be x, so it would be 2 pi times x divided by 4. 2 divided by 4 is 1 upon 2. So this is pi x divided by 2. Now I can add all these sides. The perimeter would be equal to x plus y plus x plus pi x upon 2. X plus x is 2x and y plus y is 2y plus pi x upon 2. The perimeter is given to be 60 centimeter, so I'll replace p with 60. In the first part, I need to express y in terms of x. So in this equation, I'll make y the subject, so y would be equal to 60 minus 2x minus pi x upon 2 divided by 2. This is the answer to the first part of the question. I've made an equation for y in terms of x. In the second part, I need to show that the area of plate a centimeter square is given by the equation a is equal to 30x minus x square. So I need to find the total area of this shape. The total area of this plate can be divided into area of rectangle, this shape, and the area of the quarter circle, this shape. So area is equal to area of rectangle plus area of quarter circle. The area of this rectangle is x times y, so area is equal to xy plus the area of this quarter circle. You know that the area of a complete circle is pi r square. So the area of this quarter circle is going to be pi r square divided by 4. The radius of this quarter circle is x, so the area would be equal to xy plus pi x square divided by 4. Now the equation that I have over here is in terms of both x and y, but the equation that I need to show is in terms of x only. So I'll replace this y with an equation of y in terms of x, which we found in part 1. So I'll replace y with this equation and I'll get area is equal to x times 60 minus 2x minus pi x upon 2 divided by 2 plus pi x square divided by 4. Now this equation is no longer needed, so I'll erase this. Next I'll multiply x by this bracket and I'll get area is equal to 60x minus 2x squared minus pi x squared divided by 2 whole divided by 2 plus pi x square divided by 4. Next I'll take LCM, so I'll need to multiply this fraction by 2 and this fraction by 1s, and that would give me area is equal to 60 times 2, which is 120, so 120x minus 2 times 2 is minus 4, so minus 4x square, and minus 2 pi x square divided by 2 whole divided by 4. 2 divided by 2 is 1 and plus pi x square divided by 4. The numerator can be simplified to be written as area is equal to 120x minus 4x square minus pi x square plus pi x square divided by 4. Minus pi x square plus pi x square is 0, so this is equal to 120x minus 4x square divided by 4. In the numerator I can take 4 common and I'll get area is equal to 4 times 30x, because 4 times 30 is 120, and minus x square divided by 4. 4 divided by 4 is 1, so area is equal to 30x minus x square. This was the equation that I needed to show. So this is the answer to the second part of the question. For the third part, given that x can vary, find the value of x at which a is stationary. So x is varying with respect to a. So the rate of change of area with respect to x at the stationary point would be equal to 0 because the gradient at the stationary point is 0. The equation for area with respect to x is already given. So I'll differentiate this with respect to x and I'll get dA upon dx is equal to, the differentiation of 30x is 30 and the differentiation of minus x square is minus 2x. At the stationary point, dA upon dx is 0, so 0 is equal to 30 minus 2x. Solving this equation for x would give me x is equal to 30 upon 2, which is equal to 15. So this is the value of x at which a is stationary. This is the answer to the third part of the question. For the last part, it is told that find the stationary value of a and determine whether it is a maximum or a minimum value. We know that when a is stationary, the value of x is 15. So to find the corresponding value of a, I'll put this value of x in my equation of area. Area is equal to 30x minus x square. So the stationary value of area would be 30 times 15 minus 15 squared, which is equal to 225 centimeter square. This is the stationary value of the area. Now to find whether it's a maximum or a minimum value, we take the double derivative. I raised out the solution to the previous part in which we found the first derivative, which we could differentiate again to find the double derivative. So I'll just find the first derivative again. The equation for area is 30x minus x square. So the first derivative dA upon dx would be equal to 30 minus 2x. Now if I differentiate this again, the double derivative d square a upon dx square would be equal to minus 2. And you can see that the double derivative is less than 0. And when the double derivative is less than 0, the stationary point is a maximum stationary point. So the answer to the fourth part is that the stationary value of a is 225 centimeter square and it is a maximum value. This is the answer to the fourth part of the question.